All right. My name is still Perviance, and I work at a company called AppSec Consulting down in San Jose. We do PCI compliance and pen testing work for applications, and it's a pretty cool company, and it's great working there. So we're actually hiring, so if anyone's looking for work, come talk to me afterwards. A little bit more about me. I've been doing web application security for about almost 3 years now. I also do bug bounty hunting, so I've participated in the program for a few companies like Google and Facebook and received a little bit of extra cash doing that. You can follow me on Twitter, SuperEVR, and I also have a blog, superevr.com. But first, before we get right into the presentation, there's something I really wanted to show you guys. This is pretty cool. Some AppSec O-Day. So I hope you guys are in the mood for that, because I love the smell of AppSec O-Day in the morning. All right, so who here went to this website at some point during the week? Come on, all right, cool. All right, who here went to this bio page? No, nobody? Well, because if you did, maybe you would click on that link. And if you clicked on that link right there, well, you might see that. Yeah, that's an example of some cross-site scripting on the website there, popping the cookies of the website that you're on. All right, so I was like, all right, there's some cross-site scripting on this website. What should I do with that? It's an AppSec conference, and you go to the website and you get cross-site scripting? Come on. All right, so I was like, okay, what if I submit a request? Maybe there's CSRF on the website. All right, so look at this URL. What do you think it does right there? So yeah, so the website's pretty much designed so you can choose different events and add them to your schedule. So I figured that I'd make it so if you went to my profile page, I'd automatically add my event to your schedule. All right, so it turns it from this with no star there to the one on the bottom with the star there. So maybe you were tricked into coming to this talk. Sorry about that. But I hope you enjoy it. So yeah, I was like, okay, well, I need to craft an exploit. What am I going to do here? The website actually has some really stupid XSS filters. Try to put in JavaScript : alert, doesn't work. So you're stuck for a little while. Then you try data : text HTML. There's other ways to do cross-site scripting like that. That didn't work either. This last one, this is like an HTML5 thing that's been added recently. JavaScript and : alert parentheses. Yeah, that's an HTML entity : that will render in most browsers, and then when you click it, it'll run. So it's bypassing the filter. Pretty cool, and that's the one that I was using in that link. What if you want to get script tags in? No, you couldn't do that. What if you want to get iframe tags in? No, you couldn't do that. But if you get anchor tags in, it would allow you to put links. So put those two together. Pretty cool. What if you want something automatic? You don't really want cross-site scripting that's just, okay, you have to click the link because nobody's going to click it. So you want to do something like an on mouse over. If their mouse just goes anywhere over that page, then it's going to run. So I tried on mouse over. It didn't work. It actually stripped it out and blocked it. I tried on blur, stripped that out and blocked it. But on mouse out, strangely enough, it allowed that one to go through. And that's pretty much the same thing as on blur, where you move your mouse over to an area on the page, and then you move it out of that area, and then the JavaScript will fire then. It also had a problem in the filter where if you put a slash in front of your injection, so slash on mouse over, it wouldn't block it either. So there's another little trick there. So yeah, this is the first inject right there that had the link on the page. And this is the second one. So first thing I would do is it would put an anchor tag there, and that would run the script when you mouse over it. It would create a new script tag, because in order to do the CSRF, I need to create an element, and I need to cause your browser to send a request to the website. So I create a new script tag because if you use like an image tag or something like that, you'll see a box with a question mark in it because the image isn't going to load. I just want you to send the request and not see any errors in your browser or anything like that. So that's what that's going to do. So I create that script element, and then after I do that, I delete it. That's what the remove child function is there. And at the end, I put some style in that anchor tag, because usually an anchor tag is just a link on a page, some text and underline. But you can add some style elements to it. So I changed the position to absolute and font size to 50, which means that the text takes over the entire window. So anywhere on the page, if you mouse over it, you're bound to click it, or you're bound to fire that. So really, it's simple as that to get cross-site scripted on a website. And so keep that in mind for the rest of the presentation, because cross-site scripting's a really big vector for this attack to get started. All right, so what am I really going to talk about here? Blended threats. A blended threat is a single threat, like an attacker, a single entity, that attacks through multiple vectors. And it's inherently malicious and spreads rapidly. And this is the definition from Trend Micro. All right, so you can kind of think of it like this. You have the method of entry, that's one way. Then you have the method of persistence, and then you have the method of spreading. All these different things are being put together for the blended threat. All right, so more specifically, this talk is going to be about attacks against network devices. Why? Well, attacks on network devices are pretty hard to detect most of the time. You don't run AV on them. They're also difficult to detect infections once they are. And they have kind of a non-standard upgrade model. It's not like you see a Windows update pop up every time your router has an upgrade on it, or every time your printer has an upgrade on it, you know? So they kind of tend to be outdated a lot of the time. And they're mostly ignored by users and corporations as long as they keep doing their job. So it's a pretty good vector for attack. So you might want to think about what kind of network devices you have on your network. You know, is it a security camera so that you can log in over the internet to see what's going on in your house? Is it a NAS server so you can store files? Is it a phone line, or they even make scales that connect to your Wi-Fi network now, or printers and TVs. We're going to focus on routers here, but the concepts of this talk apply to any of these devices here. The thing about these devices is a lot of them have web-based administration. This is where the AppSec portion comes in, of course. Paints a big target on these sites. All right, so what does that mean in real life? Okay. All right, well, just recently, early this October, 4.5 million DSL modems were hacked in Brazil. They were taken over. The report that I read said that there was a CSRF issue in the administration panel that allowed the attackers to change information on them and take control. They also had like insufficient authorization, where the attackers could change the passwords of these routers even if the owners of them had tried to change it to something secure. And they basically set up 40 malicious DNS servers, and once they got control of these routers, they changed the DNS servers to their own. So the talk that had this has a pretty funny conversation. They actually saw some of the chat logs of these Brazilian hackers that were doing this. So you see the conversation with Carlos over there, talking about, you know, we're activating it for 10 minutes on Bradesco, which is a banking website. And we catch a lot of info, a lot of money. We put a warning asking for the installation of a plugin, and each infection was info collected. And they didn't own any DNS servers, and so they're just scanning for the routers and modems and changing the information. And they go on to complain about the guy who originally developed the exploit and how he took all the money and went to Rio and spent it all on bad things. But yeah, the guy says last month he earned more than 100,000 reals. That's 50,000 US dollars in a month. So there's money in attacking these kinds of devices. Yeah. It's from the Kaspersky presentation from the guy who made this report. I thought it was pretty funny. All right, well, what about other devices, right? Well, you guys probably all heard about Huawei, where at DEF CON, Felix FX just talked about how they're riddled with holes and there's tons of problems in them. And there was actually a government investigation into these devices to see if maybe the Chinese government had put back doors in them, or if they're just incompetent when they created the software. But what about Cisco? I mean, surely us in the US, Cisco, we're good, right? Well, maybe not so much. If I don't have time to go over the Cisco stuff, come talk to me later. I got some really cool stuff to show. All right, so back to blended threats. All right, so there's lots of great research that has gone into browser-based attacks to attack network devices. But what if all the known ones were kind of combined into one super attack? I've never seen that before, so once I found a few different strategies that you could use, I figured that I'd connect them all together, and that's what I'm going to talk to you guys about today. So, do you guys all know what cross-site request forgery is? How it works, everything? Half of you guys' hands up. That's good. For those who don't, well, basically it's when an attack site has some code there, and it will perform an action on your behalf, usually without your own knowledge. It's a pretty simple attack vector for accessing your home network, too. So how do you use it to compromise network devices? Well, kind of here's how it would look. So on the left, you have your computer, and you're browsing the internet. It goes to the router on your network. You go to any random website, goes up to the cloud, the internet, and you reach the website. It's either a legitimate website, or it's a non-legitimate website, or sometimes it's a legitimate website with cross-site scripting on it. But I don't know where you'd find one like that. So the attacker has some code in there and says, OK, well, here's the information. Goes back out to the internet, back to your router, back to you, and it says you need to load an external resource, like an image or a script or something like that. And browsers are really good at just saying, OK, if I need to do this, I'm going to do it. So it takes that external resource, and it's like, well, it's going to 192.168.1.1. That's an internal network device. OK, why not? So it'll just send the request over there. Ooh, not this again. I think those Cisco guys got mad. Please? Okay. Let's put these guys in. So one more time for those who I was going too fast for. All right, so my thoughts were, what would be the worst case scenario here? So do as much possible with a browser. So if you have an attack site, what's the most that you could do to your victim who's just browsing around the internet? And plus, it's pretty nice because you get to let them do all the work. You're not sending information to their router. You're sending information to the victim who's sending information to the router for you. It's kind of fun to think about it that way. And evade detection, you probably won't get caught doing that, and profit. So yeah, deployment, all that's necessary is to add a small piece of malicious JavaScript to a website to kick off the attack. Easy enough. How would you do that? Ad networks. A lot of ad networks actually just say, OK, what JavaScript do you want to run? We'll place this on thousands of websites on the internet. So you can get tons of hits just like that. File sharing sites. File sharing sites are pretty cool because some of these attacks may take a little while of time. And if you've ever been in one like this, they're like, hey, sure, you can download the UCLA final match, but you're a free user, so please wait 37 seconds. 37 seconds, and you have to wait for that. So that could give you enough time for an attack to actually go through in the background. Online surveys, people fall for this stuff all the time. Social networking sites, click on a link. And oh yeah, some of you probably already went to a malicious website. All right, so once it's deployed, now that our code's been deployed, we want to kind of see what's on the network. You can't just throw blanket attacks at the network because you never know what's going to happen. It's actually possible to scan the network from the user's browser using JavaScript. There's a couple known techniques. They each have their own pros and cons. But it demonstrates the potential for really fast enumeration through JavaScript. All right, so one of those tools is called JSScan. You can just look it up online. It's pretty good. You just put in the range that you want to scan, and you put in the port number. And this is all like local for you, so you can put in that information and scan your own home network. But the same code could be repurposed with predefined information there. Another one's JS Recon. It's very similar, but it also has the ability to use WebSockets as well. That's an HTML5 technology that really speeds up the process. One of my favorites is JS LAN Scanner, where it actually has a database of default router IP addresses, and it's able to look up information and determine which device you have on your network based on the images that that device has. So, for example, 192.168.1.1/linksys.jpg will give you information. That's probably a Linksys device. So these scanners kind of just look at, am I getting a 200 OK? Am I getting a 404? Am I getting a 401 unauthorized? That kind of thing. And they have a database to know what to expect, and that's how it figures things out. So yeah, web browsers do not differentiate between resources located on the internal network and external network. So if a page tries to request an image from your local intranet, they'll just go and do it. And so that's kind of how you do it. You use JavaScript on events or event handlers, for example. So on load, it will send a request there, and if it's able to load it, that's when you can trigger a response and say, okay, well, we found something there. And if it's not, you get a kind of different response. You can use images or iframes depending on what device it is and how you want to test it. But yeah, you can also utilize cross-origin requests and WebSockets to speed things up. And this is the code of kind of how it would look like using cross-origin resource sharing. All right, so by attempting to load multiple resources within a range of IP addresses, JavaScript is able to determine which hosts are up, which ones are down. And by mapping the default IP addresses, you can get a really good idea of what's on that network. JS LAN Scanner has a database of nearly 200 devices, but somebody with some money and incentive may build a lot bigger database to find out what's on your network, what devices are there. So a determined hacker could definitely fine-tune that. I have a couple ideas for making network scanners better. A lot of routers have predefined DNS records, so it'll say, instead of going to 192.168.5.9 or something weird like that, it'll just say go to www.routerlogin.net, and Netgear routers do that. And it's supposed to be a convenience for the user because he doesn't need to know the IP address. He can just go there, and the router will actually redirect the user. He won't go off to the internet to see that website. It'll still stay local on the internal network. So that's kind of weird. So you could easily just test, okay, well, what's going on when I go to www.routerlogin.net? Same thing with Bonjour services. So Bonjour is kind of an easy domain name thing for the local network. FreeNAS, which is a free network attached storage device that a lot of people install on their home environments, sets itself up as freenas.local. There's a few other devices that do the same thing. So rather than having to do IP addresses and guess what image is there and guess what software it is, just do a predefined list of names that they already set for themselves. And also, you don't need to guess the IP address when you do that if it changes. There are some limitations, though. So for now, there's no easy way to determine the client's internal IP address without implementing some additional non-JavaScript code, like using Java. But it's not really about Java exploits or anything like that. So we're going to stick to just within the browser, bare bones, no extensions installed. Just give me HTML5 and everything you got. So what about gain control? There's authorization pages, things like this. And sometimes if you're trying to get onto a network device, you're going to get stuck there. OK, well, what's the password? But some devices do it right. For example, this Cisco VPN server says, this is your first time setting it up. Please set a password. We're not going to let you continue before you set a really complex password. But most don't. And that's why sites like routerpasswords.com have databases of thousands of router default logins and passwords. Look at that one, 1, 2, 3, 4. Routerpwn.com is also a pretty cool one because not only do these devices maybe have a default username and password, but they probably have exploits on them too. The software is not kept up very well, and routerpwn.com is kind of set up as a point-and-click exploit. If you're on a network that has a 2-wire device on it, and you click 2-wire right there, it'll give you a list of different 2-wire devices. And just find the one that's on the network that you're on and click it, and it'll give you admin access to it. All right, what about authentication when you can't find that exploit? But there's other ways to do it. Do you guys all know that if you put http:// you can put http:// username : password @ and then the URL? That works in every browser except Internet Explorer. But it's kind of fortunate that it doesn't, because that kind of breaks a lot of this attack. But every other browser, Chrome, Firefox, Safari, you can put that in the URL and you'll get right there. And it's, there's also traditional forum post authentication, but I think less home devices do that. More enterprise devices probably use the post method. But yeah, it's pretty easy to CSRF authentication. So let's say the password is the default. Go to a page that has something like this, and boom, you're actually logged into that device now. Your browser will send a request to that device. It'll say, hey, you need to give me a username and password. The attacker will supply it, admin : admin. So it's going to submit that username and password. The device will come back, that's correct. Welcome in. The browser will remember that. So every time after the user accesses that IP address, he'll already be logged in. This is how you do it with a forum post, if they were doing it that way. And it's even easier if there's cross-site scripting in the router UI, because you can do something like this, where you set an XML HTTP request to actually set a specific header. And when you put the basic authentication headers, once again, basic auth is when the box comes down and says, please type in the username and password. It's not part of the regular interface of the website. It's more of a browser thing. All it does is it takes that username and password, concatenates them together, base64 encodes them, and sends them as a header to the website. But you could spoof that if you had cross-site scripting on it.
So is this happening in the background as the user ever sees this?
If it comes up and it prompts them, and they type in the information, yeah, obviously they see it. But if you put in like that image source tag, and it's the correct username and password, the user won't see anything. All right. So here's a pretty cool thing. So what if the password's not the default? You want to brute force it. Can you brute force a basic authentication password from the internet to somebody else's internal network? Well, yeah, I found out that you can. When a successful login attempt will return a 200 OK. An unsuccessful login attempt will return a 401 unauthorized. However, this is kind of weird for a lot of browsers, because they'll prompt you. They'll say, well, I got a 401 unauthorized. What's the real password? And that's going to give away the attack. However, I found this out. This is the Chromium source code update guide. And somebody reported that should not show the basic HTTP auth dialogues for sub-resource loads, particularly images. And yeah, so to issue that, if it's from the source parameter and refers to a resource that responds, just ignore it. It's like, OK. So look at this. Chromium 13, it looks like, added that as a feature. What does that mean? That means that I can send a ton of requests to your network device, and if it's a wrong username and password, you won't see anything. So I can just keep sending them until I get the one that's correct. And as soon as I get one that's correct, I'll have a JavaScript alert come up and say, this is the correct one. Log in with this one. So you can get about 100 attempts in about 2 seconds. You can do a quick demo of that here. It's kind of I want to make sure to show you guys this, but it's kind of weird because a lot of this happens in the background. The victim would never even know. OK. All right, so I'm going to the router right here, and it's saying it requires a username and password. So this tells you that I'm not logged in right now. I don't have the credentials, which get stored in the browser after a successful login. 401 unauthorized. If a user saw that, they'd kind of freak out. However, I have this bruteforce.html page I'm going to click on in the bookmarks there. And that's basically just going to load 1,000 resources. And at the bottom of that 1,000 resource is one that's trying to log in with the correct credentials. All the rest of them are just based on top 100 lists and things like that. So yeah, you can see that's like admin colon 996, admin 997, admin 998. This one right here is the correct credential. And as soon as that request goes through, it'll immediately realize that it was able to get a correct response. And boom, it says, I found the username and password out of 1,000 tries. It took about 10 seconds. So what happens now? Well, I go to that website, type in the creds, and boom. I'm just doing that to demonstrate what's going on because you could also have a sub-resource load that would log the username automatically, but that's all invisible to them. So you can see that I'm logged in with the credentials that the brute force tester found. Okay, I'm going to need to speed it up here. And this is what it used to look like. It used to give a lot more information, but I think they changed a little bit of the code, but it still works. All right, exploit and compromise. So what about CSRF? Can you do things with CSRF to it? Well, there are browser and flash bugs in the past that allowed for CSRFing text files. So you can actually submit a text file to the browser, maybe a configuration or something like that. But currently, the way browser standards are, they don't give enough control over HTTP requests. And they can't handle binary data very well. And JavaScript kind of just gets mangled up on it, gets confused until, well, HTML5, it decided to add all those features into the browser. Cross-origin resource sharing, XML HTTP requests, file API, blobs that allows you to deal with binaries. So I was like, well, that's pretty cool. What can you do with that? Can we take over an entire network by combining all these attacks and sending a binary blob to the router? Well, of course. With our powers combined, we can. So network router plus attack, money. All right. Modifying the firmware. So in this theoretical attack, and that's really what it is. You know, I've never done anything like that, but I'm like, this is probably the worst thing that could possibly happen to your home network. And it really is possible. I've done all the research to make sure of it. You can modify the firmware for a lot of devices and just customize it any way you want. So especially this one. This is a Linksys WRT54GL. The L stands for Linux. It's running Linux. You can just download any firmware for it or an open source firmware like DDWRT. And you download some tools like Firmware ModKit. Run a couple commands to extract the firmware. Make your changes, like maybe set up a default DNS server you want to use, like your malicious DNS server. Disable firmware updates to prevent the user from going back in and fixing things. I mean, you have a lot of power there. Make the changes, you build it back up, and then now it's ready for your attack. So steps to deploying it. The victim visits the attack site. The attack site instructs the victim to access malicious firmware. And with HTML5, we can do that. It can say, grab this file, store it in memory, and then send it over here.
So how does that go undetected by the user if a device is either hot boot or hot, do a cold restart in order for that new firmware to affect?
It depends on the device, definitely. Some devices will just be like, OK, thanks for the firmware. The next time I reboot, you'll have it, because everything else is stored in memory. Other devices will reboot on the spot. So there's a couple things you can do to kind of prevent that, or depending on the device, you might not be able to.
If that happens to the user,
the typical user is just like the internet went down. Right. Oh, it's back up now. I'm good, you know? Exactly, exactly.
Those routers that use PoE and they require credentials, will those credentials still be there after the firmware update?
So it depends, because there's ways to, depending on the device, there's ways to do it without resetting the configuration, and there's ways that will reset the configuration. So it kind of depends. Yeah.
Then they'll probably just fall off, a guy will come out and fix it, and then he won't even check that it's modified.
Right. Well, because you can modify it so much, like you can give it the original interface. You don't have to keep the stock DDWRT interface. You can give it whatever you want and make it look like the real thing is still there. So here's a demo of that. I'm going to skip around a little bit because I got 4 minutes. So yeah, here's the device right here. Just showing you that I'm logged in. It's running the default Linksys Cisco firmware. I'm going to clear out my browser settings just so that I don't still have the password or anything like that. So that password's pretty much gone. I might have to open a new tab or something like that. But if you give it the wrong credentials, it'll remember those ones. So the next time you send it, it won't be the right credentials anymore. So I'm actually doing that to trick it to log out just for the demo. All that stuff can go on in the background. Because the hard part about this is how do you demonstrate it when it's all going on in the background and the user doesn't see anything, right? All right, so now I'm logged out of the router. So I set up this attack page, firmware csfu.html. Warning, clicking the button can result in serious injury or brick devices, because what it's going to do is it's going to grab the firmware that I want and send it to the Linksys device. And you can see that I'm not on my internal network. I'm on attacker.com. All right, so I click that, and I actually, you can get a fair bit of information back of what's going on. You can download the firmware straight from the internet, so you can actually have a custom build depending on what was found on the network. Firmware received, creating new request, uploading firmware. And so this part, because of the way that cross-origin resource sharing works, it actually prevents you from seeing information back from off-domain websites. There's also a part here where I double-click it, but yeah. So I'm not able to see right away that the Linksys device has accepted the firmware, and what's going to happen is the browser is going to time out. But the firmware from DDWRT is 2 megabytes. It uploads really fast. So it's probably done by now, and the browser is just waiting to time out. And then once it times out, it's like, hey, firmware upload complete. Wait a couple minutes to see what's going on. And I try reloading it a couple times, not there. So in this case, it did go down. And internet came down, and boom, came back up. DDWRT install, I'll browse around a little bit just to show you that everything's all there. It has a default DDWRT password, but of course the attacker could change that in the configuration any way that they wanted to. See the status page. So yeah, it's working. The user didn't have to unplug the device or anything like that. It all just happened in the background. So what do you guys think of that? Right, so that's what. So what do you do then, right? You own the router. What do you do then? You can pretty much do anything because you own their whole network. Any traffic that's going on, you can see it too. So you can strip out the passwords. You can strip out anything. If you were dealing with a device that wasn't a router, doesn't matter. It doesn't have to be very powerful to do a man-in-the-middle attack for the rest of the network. So you do something like ARP poisoning, and you can see all the rest of the traffic on the network, even though you don't own the router. The router is a good place to be though, because there's no antivirus running on it. And nobody ever checks those things as long as the internet's working. Here's kind of the code there. I'm going to wrap it up real quick. Code is on GitHub if you want to see it. github.com/superevr. And I called it DDWRT install tool because if your friend's like, hey, I need some help. I have one of these and I want to install DDWRT. You're like, okay, just go to this website. And you're good to go. So at that point, you have it all. And I think I'm all out of time, so thank you very much.